This is Mrs. Amiette, and this video is to help you with your mileage conversions worksheet. So at the top of every worksheet that I give you, you'll have a little need to know box, and in this box we're going to put pertinent information such as formulas and equalities that you'll need. So for this particular worksheet, you'll need the following. These are equalities. First one is 1 mile is equal to 1.61 kilometers. And the next one that we have is 1 kilometer is equal to 1,000 meters. You also need to know that 60 seconds is equal to 1 minute, and 60 minutes is equal to 1 hour. Now let's look closely at these equalities. Here we have the unit abbreviation MI, that's for miles. Here we have the unit abbreviation M, that's for meters. And here we have the unit abbreviation MIN, that's for minutes. Be very careful when you're working out your problems and use the correct abbreviation so you don't get confused. Alright, let's work an example problem. Example 1 asks how many kilometers are in 120 miles. When you're working these problems, the first thing you need to think is, what am I given? You start with what you're given. So in this case, we're given 120 miles. We put what we're given over 1 in fraction form. What we're doing is dimensional analysis, and when you're working dimensional analysis, you start with fractions. The next thing you need to think is, what do I want? Well, I want kilometers. So I'm converting miles to kilometers. We're going to do this by multiplying fractions. So for the next fraction, you're going to go up here into your equality bank, and you're going to find an equality with both miles and kilometers. So the first one has both miles and kilometers, so that's one we're going to use. And you set it up on this fraction. When you do, you put the unit that you want to get rid of on the bottom. So we're going to put miles down here, and the unit that you're going toward on the top, 1.61 kilometers. We can cancel out miles. You see that these miles will cross cancel, so we're going to get rid of them. And we're going to multiply 120 by 1.61 kilometers. And when we do that, we get 193. And put the unit down there. The unit we're keeping is kilometers. Whenever you write your answer, put a box around it so that it's easy for us to see when we're grading, and go on to the next problem. Example B. If a car is traveling at 36 kilometers per hour, how many miles per hour is this? And then it asks how many meters per second. So really we have two problems here we're looking at. So remember the first thing I told you to do, start with what you're given. You're given 36 kilometers per hour, and you're going to put that into fraction form. So 36 kilometers per hour. Then we're multiplying fractions, and the conversion that we want to make here is kilometers to miles. Hours down here in the denominator does not change, so we don't have to convert it. So again, we're going to use the equality 1.61 kilometers per mile, but this time we want miles and we want to get rid of kilometers. So we put 1 mile in the numerator and 1.61 kilometers in the denominator. Kilometers cancels. We keep miles. So we're going to multiply across the top here. 36 times 1 mile is 36 miles. 1 hour times 1.61 is 1.61 hours. Now we need to reduce this fraction, so when you do that with your calculator, you put the top number into the calculator first, divided by the bottom number. So 36 divided by 1.61, and you get 22.4, which we will keep at 22, respecting our sig figs here. And that's going to be 22 miles per hour. Now, it is acceptable when you're writing the answer to put this fraction in this horizontal form, but when you're working the problem with dimensional analysis, you should never put the fraction in this form. This is only acceptable when it's within a statement. So I'm going to put a box around that answer, and I'm going to do the next conversion. Our next conversion is going from 36 kilometers per hour to meters per second. Or we can just go ahead and convert 22 miles per hour to meters per second. Let's do that. So we put our answer down, and that's what we're given, 22 miles per hour. We've incorporated the unit into the whole fraction here. We're multiplying fractions. First, we're converting from miles to meters. That'll be our first set of conversions. And then the second set of conversions will be going from hours to seconds. All right, so we want to go miles to meters. To get to meters, we have to go through kilometers again. So we know that there are 1.61 kilometers per mile. Now we're in kilometers, we need to go to meters. So there are 1,000 meters per kilometer. I'm going to go ahead and do some canceling here. Get rid of miles, get rid of kilometers, and right now I am in meters per hour. So we got to get rid of those hours now and go to seconds. So we know that there is 1 hour per 60 minutes, and remember, I'm just getting this from our equality bank up here that we made. Then we go from minutes to seconds, and we know that there is 1 minute per 60 seconds. Notice how I set these up. I want to get rid of hours down here, so I put hours on the top, minutes on the bottom. Cancel out the hours, now I'm in minutes. I can cancel out these minutes, and now I'm in seconds. So the unit on the top of the fraction is meters, the unit on the bottom is seconds. So when I find the answer here, it's going to be in meters per second. So I multiply across the top now. 22 times 1.61 times 1,000 gives me 36,064 meters. 1 times 1 times 1 times 60 times 60 seconds gives me 3,600 seconds. Put this into the calculator. Top number goes in first, divided by the bottom number, and I should get 10 meters per second. Put a box around it so it's easy to spot. Example C is a little different. We're just using algebra to solve for a variable within a formula. The formula that we're given here is V equals delta D over delta T. This whole arrangement is a formula. Each part of the formula is a variable. Delta means change. So the variable v stands for velocity. Velocity is equal to the change in d, that's distance, over the change in time. We want to solve for delta t. That means we want to get delta t all by itself on one side of the equal sign. Some of you may have been taught a triangle method for doing this. You are not allowed to use that in this class. In this class, you have to use algebra, and you have to show all of your work. So the first thing that we're going to do is we're going to get delta t down here out of the denominator. That means we're going to multiply by delta t. We can multiply by delta t over 1 or just by delta t. It's the same thing. The rules of algebra tell us that whatever we do on one side of the equation, we have to do on the other side of the equation. So we're going to multiply by delta t over here as well. Now, we're going to cancel out delta t and rewrite our formula. So what we have is delta d is equal to delta t times v, times velocity. Gives us distance. But we don't want distance. We want delta t. So now we've got to get rid of v over here. So to get rid of velocity, since we're multiplying, we're going to divide out velocity. Rules of algebra tell us whatever we do on one side of the equation, we have to do on the other side of the equation. So we're going to divide out velocity over here. Cancel velocity, and we've done it. We solved for delta t. Rewrite the equation. Delta t is given by delta d over velocity. You must do this algebraically. You must show your work. On all of the problems on this worksheet, you must use dimensional analysis. That's the multiplying the fractions. You must show your work. Don't forget to put the unit by your answer. The whole point of doing this exercise is to find the correct unit. So you have to put the unit down. Okay. Number 1 is just like example A. That should be pretty simple for you. Number 2, also start with what you're given. Set it up in fraction form. Number 3 sometimes gives students problems because our unit is a little different. You're going to set number 3 up like this: 35 meters per second. And then you're going to multiply. You're going to convert meters to miles. So first you'll go to kilometers, and then you'll go to miles. Then you'll do the second part of the conversion, which is going from seconds to hours. So first you'll go to minutes, and then you'll go to hours. Number 4 is very much like number 3. Number 5, you've just got one conversion to do, meters to kilometers. Seconds does not change. Number 6, same thing, meters to miles this time. Hours does not change. 7 is like 5 and 6. And 8 is like 5 and 6 and 7. You've got 2 conversions on number 9. You're going from meters to kilometers, and then seconds to hours. 10, you're going to have to write this formula out as we did in example C, but this time you're trying to get D all by itself on one side of the equal sign. And we have a different formula for number 11. We've got the acceleration formula. So you're going to write this out. Acceleration is equal to the change in velocity over the change in time. And again, you're solving for t. So you're going to follow the steps that we did in example C for number 11. All right, I hope this helps. Good luck. Check the calendar for the due date.